Hi everybody, today we're going to talk about radians, which is the second way to measure angles. Hopefully you remember that the outside measure of a circle is called the circumference. A portion of the circle is called an arc. An arc could go the full way around the circle or go past the beginning point. A central angle is an angle drawn from the center of a circle that intersects the circle at 2 points. So what you can see is the angle intersects the circle and it forms this arc. The measure of an arc is equal to the measure of its central angle. So for example, if we had an angle of 45 degrees, then the corresponding arc would also be 45 degrees. An arc that is equal in length to the radius of the circle is called a radian. So in this picture, we have the radius r and we have an arc with that same measurement. So let's go back to talking about the circumference of a circle. The circumference of a circle has a measurement of 2 pi r. We know that a circle has 360 degrees. When we put those two things together, that tells us that 2 pi r is equal to 360 degrees. So a complete revolution of 360 degrees will be equal to 2 pi radians. Remember that the radian is an arc that's equal in length to the radius. If we take half of a revolution, then we have 180 degrees, which would only be pi radians. Our formula to convert between degrees and radians will be reliant on the equation 2 pi r equals 360 degrees. So we'll start by solving for r, which would give us 180 degrees over pi. This is our first formula for trig, so it's important that you write this down. We actually want to write two formulas down right now. These are our conversion formulas. So to convert from radians to degrees, we're going to multiply by 180 degrees over pi. If we want to convert from degrees to radians, we will multiply by pi over 180 degrees. Again, write this down for now. I'm going to show you how that works. So let's try these examples. Let's convert from degrees to radians. So my first one says 90 degrees. I'm going to multiply by pi over 180 degrees. So what's happening here is we're getting rid of the degrees. So 90 goes into 180, gives me 2. So in radians, I have pi over 2. Let's do the same thing with 35 degrees. I'm going to multiply by pi over 180 degrees. So it's important that the degree part cancels out, and what we're left with is an answer that's in radians. We'll start by writing 35, pi over 180. I can simplify this because 35 and 180 are both multiples of 5. So if I divide 5 into 35, I get 7 pi. 180 divided by 5 is 36. I'm going to leave it as 7 pi over 36. I like to leave fractions over having decimals. I want to have exact answers, not approximate answers. Let's go the opposite direction. This time I have radians. I want to switch over to degrees. So pi over 4. I'm going to multiply by 180 degrees over pi. So what you can see is the pi is going to cancel this time. Pi goes into pi. I can divide 180 by 4, which gives me 45 degrees. Make sure you're paying attention to units. When I put things over to radians, I shouldn't have a degree. When I convert things to degrees, I want to see that degree symbol. The next one says 4 pi over 5. So again, I'm going to multiply. I have 180 degrees over pi. The pi's cancel. So now we have 4 times 180 over 5. Let's divide 180 by 5, which gives me 36. I have 4 times 36. So my answer is 144 degrees. There are angles that we use a lot in trigonometry, so it's good that you see these angles and you see their conversions between degrees and radians. Also notice there is a little duplication. So 0 degrees is also 360 degrees, so it's all the way around the circle, which is equal to, in radians, 2 pi. The next angle we look at a lot is 30 degrees, which in radians is pi over 6. Moving up to 45 degrees, that's pi over 4. 60 degrees is pi over 3, and then 90 degrees is pi over 2. Coming back down to the left, I have 120 degrees, which is 2 pi over 3. 135 degrees is 3 pi over 4, 150 degrees is 5 pi over 6, and then pi is 180 degrees, so there's that straight angle of 180. 210 degrees is 7 pi over 6, 225 degrees is 5 pi over 4, 240 degrees is 4 pi over 3, 270 degrees is 3 pi over 2. 300 degrees is 5 pi over 3. 315 degrees is 7 pi over 4. 330 degrees is 11 pi over 6. Now this is a lot, like we said, but there are certain angles you really want to know. You want to know 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are where we're hitting the x and y axis as we go around the quadrants. You should spend time looking at this type of graph. Look for some similarities here between the pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Same thing when you look at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, right? So start to look for consistencies, get familiar with these. You are going to use these throughout your study of trigonometry and on to calculus if that's where you're headed. One way to get familiar with this is to get a blank unit circle and fill in these degrees. There's plenty you can find online. I'll put it in the class resources as well. But like most things that we learn through repetition. So sitting down, writing these out a few times will really help. Of course, you can have it as an aid and something to look at. But as we go through lessons and we use these angles all the time, you will find the class easier if you know most of these basic angles.